Hey friends of the Marcus Performing Arts Center, Dr. Coco here at Mad Science Laboratories. Thank you very much for joining us. I've got a couple of really cool science experiments that I'd like to share with you that you can do at home, finding only a couple of things around the house. Now today, all of our experiments have to do with a concept that we call density. And a great demonstration of it is this little science demonstration bottle that I have here. It's called a density bottle. Now, if you look very closely at this bottle, you're going to notice right away that we have some different colored beads floating right in the middle of this clear liquid. Now, these are just observations that I'm making looking directly at it. But here's the fun riddle about this bottle, is that it raises a lot of questions. First off, how are these beads sitting directly in the middle of the liquid? And why does the bottle seem to act in a certain way whenever I shake it up? Here, let me shake it up and I'll let you take a look very closely at it and see if maybe you can figure out why these beads are doing what they do. I'm going to give the bottle a quick shake like this, and then if you notice, just watch what the beads do. As you can see, the white beads are starting to float all the way up to the top, and the blue beads are sinking all the way to the bottom. And now, if we watch the bottle slowly, you should start to observe that even though the beads have separated themselves, they are slowly starting to move in the bottle. The white beads are starting to sink down to the middle, while the blue beads are starting to rise up from the bottom. And they're going to meet directly in the middle and start to essentially just kind of balance and sit there. Now, the riddle behind how this bottle works is actually very, very clever and has everything to do with density. You see, the trick of this is that there's actually two different clear liquids mixed together with those two colors of pony beads. Now, right now, the white beads and the blue beads are the middle density, which means that they're heavier than the stuff that's above this clear liquid that's above the beads, but they're lighter than the liquid that's underneath. Now, I can tell you, because I put this thing together, that the clear liquid on top here is a very light type of liquid called isopropyl alcohol. And the clear liquid on the bottom is salt water, which is salt that's had water mixed with it. Now, that is very, very heavy compared to the alcohol and these two different beads. Now, when I shake the bottle up, not only am I mixing the beads up, but I'm also mixing up those two different clear liquids. When salt water and isopropyl alcohol are mixed together, it is actually heavier as a mixture than the white beads, but they're lighter than the blue beads, which means that as those two liquids are mixed together, they're going to push the white and the blue beads away from each other until the isopropyl alcohol and the salt water start to separate, because the salt water is very, very dense and it's going to want to sink, and the isopropyl alcohol is much lighter and that's going to rise up to the top. As those two liquids start to separate and the alcohol goes up and the salt water goes down, the alcohol is now lighter than the white beads, pushing the white beads down, and the salt water is heavier than the blue beads, pushing the blue beads up. It's a really cool illusion, and it's a great way to explore density. Now, the experiments that I have work on these same subjects, and you can make them very easily at home. We're going to be making a couple of different things, and the first one I'd like to show you is a very cool demonstration of just how fluids work, and you only need to find two different liquids in your house to make this project. The first thing you're going to need to find is some vegetable oil or cooking oil. Now, cooking oil is very light. It's not as dense as regular water, which means that when we mix the two together, the oil is always going to float on the top of the more dense water. For this experiment, like I said, you need water. You are also going to need to find access to some water in order to do this. The final thing that you're going to need for this project is a clear bottle, something that you can seal up when you've mixed all the chemicals in there. Now, I know I've been saying a lot about working with chemicals today, and if you've noticed, I'm making sure that I have all the safety equipment that I need in order to practice chemistry and working with all of my different science equipment here very, very safely. I have gloves to protect my hands from any of the chemicals. I have goggles on to protect my eyes from anything that would splash up in my face. And I also have a lab coat to protect all of my clothes from any chemicals spilling on them as well. If you're going to try these experiments at home, I do highly recommend that you make sure that you also give yourself all the safety equipment that you can to make sure that you're as safe as possible. Now, once you've collected all of these different pieces of equipment, now it's time to start mixing them all together. Now, the first thing I like to do is I like to put some water into our clear bottle. And you don't have to fill it up all the way. I recommend putting about half a bottle's worth of water right in to the bottle itself, just like that. Now, because the water is heavy, it's obviously just going to sit on the bottom. The second trick that we're going to do is we're going to add the vegetable oil to the water that's already in the bottle. Now, the first thing you're going to notice when you pour this oil in is that just the force of the oil falling and being pulled by gravity is going to make the oil drop almost all the way to the bottom of the bottle of water. That's just because of the force of the oil falling. But because this oil is less dense than the water that we're pouring it into, over a couple of seconds, that oil is going to start to separate and float to the top. And as you can see, even when it's mixing together, the oil kind of wants to stay blobbed together with all the rest of the oil molecules that are around it, which is why we see these nice little kind of blobs of oil kind of swimming around inside of there. Now, once we have these two chemicals sitting together, we can start to already see not only how the oil is separating and floating on top of the more dense water, but also we can start to see how fluids react and move as we shake the bottle back and forth. Now, to give this a little bit more of a pretty color, I'm going to add a little bit of food coloring to my bottle as well. Now, the fun thing about food coloring is water-based. That's why it's safe for us to use with food. It's essentially just water with a little bit of pigment or dye mixed in with it. Now, if you take a close look at my bottle, I'm going to drop a couple of little drops of, I'm going to put green in. I'm going to put some green food coloring into my bottle. And as you can see, the food coloring drops, once again, don't want to mix with the oil, but they're so heavy that they do sink underneath until it finally touches the water. When it touches the water, the ink that's in the food coloring is going to actually start dispersing with water and mixing around. Now, sometimes you may have to give it a little bit of a shake to get it to mix, but as soon as it starts, you're going to see a real nice kind of burst of color as all the food coloring stays separate with the oil until it touches the water and then starts to mix and complete its journey. Now, that's a really cool look just by itself. And once you have that separation in color, you can really examine, once again, the different layers and how they move. If you'd like to add an extra challenge to this bottle, you can look around your house and see if you can't find other liquids that may be heavier than water or lighter than oil and try mixing it in there and making some more layers as well. I would recommend starting with possibly some corn syrup or maple syrup or something like that. Just pour a little bit in the bottle and see where that liquid sits between all the other layers of density that you have in front of you right now. Once you have this bottle completed, you have created a wave modulator, which is really cool and very soothing. However, once you've completed this project, you are one step away from making another really cool density water and oil experiment. And this is a classic one that I learned when I was a very young scientist, and it's called essentially an Alka-Seltzer lava lamp. In a moment, we are going to be putting an antacid tablet into this water and creating a reaction that's going to start this entire mixture of water and oil to bubble and get all violently mixing together. Now, in order to do this, I want to tell you a little bit about the chemistry behind these antacid tablets. Most antacid tablets that you find are really a combination of only two different chemicals. One is citric acid, and the other one is sodium bicarbonate. Sometimes we call it baking soda. Now, these two chemicals are mixed together in this little tablet. I'm going to take this one and crush it up so it's going to be easier to mix with everything in the bottle. But the acid, the citric acid powder that's in this antacid tablet, as soon as it touches the water, it's going to start dissolving and mixing with the water. And because it's an acid and it's mixing with water, it's going to slowly make that water acidic as well. Now, that's very important because we need the water to be acidic in order to make it react with the other chemical in our antacid tablet, which is sodium bicarbonate or baking soda. Now, when baking soda mixes with any sort of action or any sort of acid, we get a reaction where the baking soda is going to release carbon dioxide gas, which is why you see lots of little bubbles coming up from these tablets when I drop it in. As those bubbles start to rise through the water, the bubbles are going to make the little drops of water that they're touching less dense or lighter than the oil itself. And the bubbles are actually going to pull the water up through the oil until the bubbles reach the surface and pop, at which point that droplet of water is going to become heavier than the oil and sink back down. Now, depending on how much antacid tablet you put into your bottle, you may be able to see this reaction occur for several times over and over again. However, when the reaction is done, if you have more antacid tablets, you can continue to put this in and restart the chemical reaction several times over. Here, I'm going to put it up to my close-up camera and you can take a look. Now, I do recommend that if you have a funnel, this is a very handy thing to help you make sure that all of your chemical gets into the bottle itself. But as soon as you drop it in, the antacid tablets are going to start reacting with the water, turning the water acidic, and then releasing a whole bunch of carbon dioxide gas until you have some really cool little bursts of blobs of color rising up through the oil. Here, I'm going to drop my other antacid tablet in there, and we're going to restart the reaction to get some really cool reactions going. Beautiful demonstration, not only density, but also of chemical reactions between acids and bases as well. It's a super fun experiment, and I hope you really enjoy it. Now, speaking of large reactions and explosions and things like that, I have one more experiment that I'd like to share with you. And this one is what I like to call food coloring fireworks. Now, in order to make this, we are going to be mixing together the same chemicals that we made to make our wave modulator and a lava lamp, but we're going to be mixing them in a different way. I would like you to first start with a little bit of cooking oil. Now, I have a small little beaker here. You can mix all this in a glass or anything else that you have around the house. Now, you're going to start with just vegetable oil. So I'm going to drop some of that in there, and then I'm going to add some food coloring to the oil itself. Now remember, the food coloring is water-based, which means it's not going to mix with the oil. It's going to stay separate in just these little blobs of whatever color. I'm going to put a little bit of green in there, and we'll put a little bit of red and a little bit of blue as well. So we're going to have 3 different pigments that we're going to mix together. Now, once those are in the oil, you're going to want to take a spoon or a fork or a stir stick like this and mix up the oil and the food coloring so that all the food coloring gets separated into lots of little droplets. If you can see in my beaker, all of those little droplets of color are still separated because they don't want to mix with the oil. But they're still just kind of floating around in the oil, which this looks really cool by itself. But now we're going to mix that with a large thing of water, and we're going to see as the oil droplets slowly sink down through the oil, mix with the water, and we should see some really cool bursts of color. Here, check this out. I'm going to add the oil with one quick little extra stir. And again, the oil first is going to try to mix with the water, but it's not going to be able to. The oil is going to rise up to the top, and then the heavier drops of food coloring that are mixed in with the oil are going to start to sink down until they touch the surface of the water. As soon as they do that, you should start to see some little bursts of color as every single droplet of food coloring starts to mix with the water that's happening around it. It's a really beautiful reaction that, again, shows you not only density, but how water can actually mix with other different chemicals as well. As you can see, we have some really nice bursts of color mixing around. It's a great way to see density, and it's a beautiful way to spend some time at home. I hope that you all enjoyed these experiments. I'd like to thank you for joining me in the lab. I hope that you try out each one of these at home and continue to explore the world around you. I'd like to thank you very much for joining us. Another big thank you to our friends at the Marcus Performing Arts Center for inviting us to share all these experiments with you. And until we see each other again, everyone, happy science.